So hello everyone, thanks for coming to this talk. My name is Nikolai Kudasov, and today I'm gonna talk a little bit about my experience of constructing a DSL for composable reports at work. But also I hope that some of the key ideas will transfer to you and you will be hopefully able to apply some of the ideas to your own work and benefit from that. So a little disclaimer about myself. So I'm a CTO at GetShop TV, which is a startup doing interactive television platform in Russia, and we use Haskell mostly for the backend. And I also teach Haskell at Innopolis University in Russia. So, and yeah, I'm a big Haskell fan. I'm actually, like, most of my commercial use of programming languages is involved with Haskell. I also did a little bit of Clojure, but other than that, I'm mostly ignorant of like OP programming in production. That somehow missed me. So there's that. Okay, so at GetShop TV, one of the things that we have to do is to provide reports to our clients, which are like advertisers or their clients or some other partners that have to see some numbers. And what format do they accept? Well, obviously Excel, right? So we have to generate a bunch of Excel reports based on our data and provide those reports to our partners and clients. So, and this is one of the simple reports that we have, like the shape of it that we have to provide. And so it has some data in it for days, and it has some header. Well, you probably recognize the structure as you probably used something similar at work as well, right? So, how do you do this? How do you build this these reports from Haskell? So there is this library called XLSX, which is able to read and write Excel files. And you can see here an example from their documentation that basically builds a very simple file with just 2 cells. And this is the relevant part where they create a cell at position 1, 2 and a position 3, 2. So you can see from this example alone that this library is actually pretty low level. So it's great in that it allows you to do a lot of stuff with Excel spreadsheets. You can do a lot, including styles and various things, crazy things that clients sometimes want to see in their reports. But it is still low level, so you have to access these cells on an index basis, and you have to merge cells manually and all that stuff. So the first code that was built in some sort of report in our system that used this library, like the first ever approach, used just this direct approach, and this is just a part of it. And if you just zoom in, you can see that first of all, there's a lot of repetition, like text cell. Okay, this is for headers. Of course, there's going to be text cells. So this can be factored out, obviously. But there are also some other things. So I reducted the actual headers, but never mind that. To the left, you can see there are actually coordinates for the cells for headers. And so this is something that a human should not do. Well, in my opinion. So this should be automated somehow. Now here's some example for values, and here you can see different types of cells, double cell and formula cell. And another thing that you can see here is that formulas are encoded directly here. So you have to know that you have to reference E3 here somehow. Again, ideally, this should be done by a machine, not by a human being. So this is very error prone, as you can imagine. So this is not something that we wanted to keep in our code base. Oh, by the way, there's also this separate thing that tells it which cells to merge. Okay, so this is actually terrible. So after seeing this first iteration, we immediately decided that it's not a way to go. So we have to build some sort of DSL to support our workflow. So the first thing is basically what we wanted is maintainability. So we wanted to maintain all these report templates. But also we had several types of reports that had very common parts, so we wanted to reuse those as well. Okay, and obviously we wanted to do this declaratively without any explicit indexing, and ideally we would also like to have some extra type safety if possible, and we'll see an example of that with subreports. Okay, so in order to achieve all that, we have to analyze how do we approach building these reports. Now, what is the structure of this report? This is, of course, a simplified thing, but still. So one way of looking at it is to split it into header and data rows and some data footer rows maybe, and see it like that. That doesn't actually give us much, right? So what is another way to look at this? So do you see a tree here, or maybe a forest, right? So although in Excel spreadsheets you can merge cells in crazy ways, in practice, headers are most certainly trees, right? So we can split this in this way, and we can actually see that headers at least form a tree. But what's interesting is that we want a header, all cells under a certain header, to be basically of the same type of cell, right? This is like, here we only want to see percentages, and we probably want the same formula there, and things like that. So actually, this is a tree where we have header names as nodes, and we have columns as leaves. Okay? Good. So now keeping that in mind, we can go and start building a representation in Haskell for that. So the first thing, of course, is to introduce a tree data type, which is just yet another version of a tree that you can implement in Haskell, right? And we are actually interested in forests, so this is just a list of trees. So this is very simple. Now, a report template is now a forest where labels on nodes are header names, and leaves are cell templates or column templates. So what is a cell template? What do you think? What do you think can be used in a functional language?
Function?
A function, yeah, that's great. That's actually exactly the first approximation that we can do, is just to introduce a function. But what is this function about? What does it do? So this row here can be actually, you can spell it either way. You can spell it with A or O. It makes sense both ways. So raw here is the data that you process somehow to split it into values that you put into the cells in a single row. Okay? And the cell type here is, right?
Instead of using the raw record, could you use a lens to only expose the section of the record that column needs to the function?
You could. We will see subreports that do a similar thing. I don't think that, well, you could use lenses, but I think that's an overkill because you only need a getter.
Yeah.
Okay, but yeah, the idea is similar. Okay, so now we have a tree that has basically text in its nodes and functions in its leaves. And okay, so now another thing is, how do we construct this? How are we going to construct this template in the code? So we obviously will have some things that represent these columns and things that represent headers. So how do we construct this in the code? We compose stuff together, right? So how do we compose it? So here you can see that, first of all, some columns have just one header that we can just put on top of that column right away, okay? But then to put this header, say, for these two columns, we have to first concatenate them into a single two-column report, okay? And this is an important, it's a very simple but important operation, concatenation of two report templates. Okay, and now we can put more headers and then concatenate some more, put more headers, concatenate, put more headers, concatenate, and there's our report. Okay, so I hope this visualization helps understanding the idea of what is going to happen in the code. Okay, any questions so far?
Yeah. When did the totals get added in? We didn't talk about the totals. No.
Okay, yeah, totals for now is just a row. Okay, it's just another row.
Since it's a tree, there's no order information. There's no ordinal information associated with the columns.
Why? There is, of course. Yeah.
Okay.
Yeah. It does matter to our clients. It does matter to us. And lists are typically ordered by default. So we're using lists, not sets, right?
Yeah, so the forest is ordered because it's a list. But
yeah, but tree has tree is either a leaf or a node with a forest of subtrees, right? Okay, so now that we know the representation, now we can introduce some of the basic building blocks that we can use later to write the report templates. So, and the basic things are to introduce a column, and this is basically some wrapper around a leaf that is going to create a leaf, and some wrapper around node that will create a node. And for the concatenation, we'll have an operation cat that will concatenate two report templates, right? But so instead of using concatenation is an operation that is how do you say it? It's associative, right? Because it doesn't matter in what order you concatenate stuff. And if you really think about, you can imagine an empty report, right? Where you just don't have anything. So you can have an empty report, and obviously this is, I'm sorry for this animations, this is exactly the interface that Monoid provides. So we're actually going to treat reports as monoids in this way. So empty report and horizontal concatenation. Okay, nice. So our the basic interface is building a column, building a node, and the monode interface. Okay. So, and here's an example of how you can build a report template, for the report that we've seen before, using this interface. So you can use this angle brackets is the monoidal operation. Empty we don't use anywhere, so we only care about the semigroup. And that's basically it. So you can see that I use indentation to emphasize the tree structure of the report. Okay, and you can see that for columns I use these functions which I did not introduce obviously, but this is just some function that takes a field or extracts information from day stats. Okay. Okay. So the problem with so this is actually beautiful. I find this beautiful. I don't know if you agree or not, but there are two problems. So one problem is that it looks a little bit lispy. I also forgot another closing parenthesis here, and it cannot support formula builders. So remember that we also want formulas in our reports. Well, because clients want them, right? So how do you do formulas? You have to reference some other cells in the same row, or maybe something else. So how do you do that? With this monoidal interface, it's actually not clear. So let's look at these formulas a little bit closer to understand what we can do about that. So here's like a sample of a table where we have 3 rows, we have 2 numbers, and a percentage, which is the ratio of one number to another. Okay. So we have obviously indexes for columns and for rows, A, B, C, and 1 to 3. And the formula for this cell is just A1 divided by B1. Okay? But obviously the formula is not the same for all the cells in the same column, right? The row index differs. So first observation is that whenever we build a value that we want to put in this cell, we have to know information about which row this cell is in, right? Okay, so another thing is that if we want to insert some column, say here or at the beginning, anywhere, then now our formulas change because they no longer reference B column, but now it's C column, right? So this again messes up the columns. So the second observation is that the cell needs also information about which column it is in, or what's the current offset. But also, when we concatenate report, that information about cells changes. Okay? So how do we deal with this, with all these things? So first of all, we can add cell coordinates directly into our cell template. So now our function takes both the data that it needs and its position, so it can know where it is and maybe make some relative computation, right? But we also want to reference other cells, and we don't want this like, I know that the cell should be like three columns away from me. I want to actually get the information when I build the template and use that, right? Does that make sense? Okay. So an idea here is basically to treat this column offsets or indexes as something that happens on a side to our declarative definition, and treat these indices of cells as side effects. So how do we do that? So we wrap our definition in a builder setting, which is probably familiar to many of you because there are like string builders and all other builder stuff. So for now, our builder state will only have the offset, and the offset is basically the rightmost column. So that when we add another column, we know that it's offset +1, and so on and so forth. And so the report builder itself is just a well, I can just reuse the the monad transformers that are already available in MTL, so or in transformers library. I can use writer to actually compose the report template, and I can use state T of this report builder state to keep track of the current offset while I'm building this report template. Okay? So again, this part handles the state, the column offsets, and this state basically writes the report template. And if you know writers in Haskell or in any other language that has writers, what they do is they have this context where they can write or basically append to whatever is already there, right? And what do they use for this append stuff? They use monoids. But we know that our report templates are monoids. We can always add to the right, right? So this is what we're going to try to use. And obviously, if we have something as a report builder, we can easily get a report template out of it. We simply have to start like at the left top corner of the report and go from there. Okay? Does this make sense? Any questions? Okay. So we update our building blocks now for the report builder. they don't change much. So now we have a function that also takes cell coords. This doesn't change except for the type. Before it was report template, now it's report builder. Okay. So what about report concatenation? So before we used this monoidal operation to concatenate two report templates. Can we do something similar with two report builders? Any ideas? Sure.
Report builder is a monad, right?
Yeah.
So can we use an applicator?
We can use just the semicolon, right? Yeah, bind without any without accessing the contents, the result of the builder. We can just use this greater than or just a semicolon, right? It's also in the applicative. It's star greater than, right? It's this thing. So and if we think about Of course, if you think about these operations, if you know them, it makes sense. But for maybe another approach to this, monads can be used in do notation, right? So we can just forget about the interface of a monad and just think, okay, so we can now use do notation. So we can have one builder on one string on one line, and another builder on the next line. And what will happen is the first one will build the left part of the report, and the second one will build the part of the report after that. So just putting things after each other in imperative manner will actually give you the concatenation of the results of those things. Okay. So here's an example of the same report, but now with formulas. So what happens here is, as you can see, we've changed our parentheses and the diamond operators to just do notation and putting things under each other. We still use indentation now both for do notation and to emphasize the tree structure. And you can actually even get rid of the $signs if you use block argument extension. But yeah, arguably this has a little bit less distracting elements. Now the interesting part is where we define formulas, and what we do is now column. Let me go back to this building blocks. So column actually now returns the coordinates of that of the cell that was built. Right, and we can use that, and note it just propagates the result. Okay, it doesn't do anything to that. So when we do when we do node of a column of something, what we get as a result is we get the coordinates of that cell, and now we can use that and the coordinates of the other cell to make a formula with those two cells. Okay? Does it make sense? Okay, so what we've achieved here is now we have more or less type-safe way. At least we don't deal with indices manually. Yeah, question?
So how do you, it seems like you're composing left and right, so how do you refer to some elements on the right?
On the right, oh, you use recursive do. Right. So typically that doesn't actually happen. I don't think we have any reports that have to reference something on the right, but you could do that easily with just recursive do, right? Okay. So now the only thing. So do you have any questions so far about the approach and the structure of this? Okay. So now the thing is that we have two blocks of code that are basically identical, except they use different values here, but all the other stuff is the same, and the name for the groups is different. So what we want is to put this to factor this out in a sub-report. And we can obviously do that. But now what's the type of this report? So we could obviously pass the functions to get values here and here as parameters to this factored out code. Or we could factor this, sorry it's not shown on the slides, but so we have this daystats data structure that has some stuff. And if we can just extract a substructure that has all the necessary information, we can just access that. Okay? So instead of daystats, it now accepts started finished stats, which is just a little part of our report, of our data. And we use that to fill these two columns and then to make a formula. Okay? And then, yeah, so there's a different type here. And what we do here, we use another primitive that I haven't introduced yet called subreport that basically does a subreport with this subreport, but it takes a different part of the original data structure. Here it takes the total and here it takes the unique. Okay? Make sense? Any questions? Okay, so then a question to you is what's the type of subreport? Can you see what the type is? Sorry? Report. So it takes two arguments, right? So the first argument is.
Oh, sorry. I thought you meant the return type.
No, the return type is the report builder. Yes, that is correct. And this thing we know is a report builder.
Right.
Right. So there's also another argument here. So what do you think that one does?
The lens.
Some kind of aggregator for rows.
No, so it's actually just a function that extracts this data from daystats. Okay?
Together.
Okay.
It's just together. Yes. We don't need the lens because we only do it one way, at least so far, right? So the type of subreport is, so we have a function that takes whole and gets a part of it. We have a report builder for a part, and then we can have a report builder for the whole. Okay?
Sounds like local.
Sorry?
Sounds like
Local?
Yes.
No, that is not a local. Local, you mean in modern reader?
Yeah.
It has the same type.
Okay.
The context doesn't change. This is actually, yeah, so the bonus question is which abstraction matches it? Does anyone know? Sorry?
Contravariant?
It's contramap. Yeah. So it's like functor, but in reverse, right? Because if it was a functor, we would have this function the other way around. Yeah, so you can actually like reflect on that and think about like, okay, we'll see later maybe. Okay, so that's basically the gist of it. This is these are all like column, node, and this subreport are the main building blocks, and of course the monoid interface now is the main building block for our DSL, and we can actually happily write a lot of reports, reuse stuff, and it's actually working out quite nice for us. So now, what do we do with this template in the end, right? So we want an Excel file or something like that. So what we do is we fix the cell type to an Excel cell, and the data again can be still anything. And so this function just takes a report template, and for some reason we actually differentiate the first column, and we give it a separate name, and so this first text is the header for the first column, and this is the value for in a row for the corresponding row. Okay, so you just give it a stream of data and it produces a report. Okay. Questions? Okay, so
Give it a stream of data. Can you build it build a file incrementally, like a conduit or something, where you just output the headers and then. In other words, constant memory. Can you build it like if you have a stream of data coming in? Can you build it?
I'm not sure. That depends on the XLSX library.
Right.
I don't think they support that. But we did not have any issues with that. I don't think we have like really huge reports. So the implementation for this is actually like it's not super short, but it's small and it's pretty straightforward to implement. So it's just technical detail. The important part of this talk is the interface that you're facing, right? So, right. So now I've basically told you what we came up with. And what we use actually at work to build reports, but we also like had a few thoughts of what if we wanted to do something else. Like one thing that you might want to do is you might want to actually extract data for every cell using some other context, maybe I/O, maybe some other thing. I don't know why, but you might want to. So for that, you could, again, just edit a cell template a little bit and add like a context here, so a type constructor that you can control and you can work with it. And because our thing is declarative and cells typically do not, what we put in one cell should not depend on like contextual information that we get when we build another cell. It's actually okay to just use applicative here. So you can do that. What are other things you can want to do? You might want to have a similar tree structure on the side, right? Which is commonly used. So what you can use there is, well, report template is actually that tree structure. So instead of giving it a list of rows, you can give it a report template of rows. And here I'm using the unit, but in theory you can use another input data type and provide that to generate data here and then go there. Okay. So, and yeah, if you wanted to like go crazy and generalize this, I've tried. I also tried some approaches with free monads because, you know, trees and forests, you can generalize those, right? Just put free instead of forest here and you get yourself a nice generalization. Well, you can do that, and but I found out that it is somewhat hard to work with. So at least at work, it's easier to work with the more concrete stuff. But yeah, maybe some of you know like some data type that actually exists in some maybe Comets library that does already all this. That's quite a possibility. Yeah, so here the key feature is that I don't use a function, I use a profunctor here because, yeah, I might use some effects, I might use some extra stuff, I might not use functions, I might use maps or something like that. Yeah, but it's weird. Okay, so that's basically it, I think. So we are hoping to open source the code that we already have. Right now it's a little bit too tight to our code base. I hope that we'll be able to release it soon. It's going to be called Clerk. Yeah, so that's it. Thank you.